Imagine that you have just bought the car of your dreams. It is powerful, smooth, and has that latest generation automatic transmission that changes gears with the subtlety of a whisper. One day you arrive at a traffic light that you know takes an eternity. Out of a mixture of comfort and an old habit inherited from manual cars, you put the lever in the parking position while you wait. When the light changes to green, you try to put it in drive, but the lever feels as if it were welded to the chassis. You hear a terrifying metallic crunch coming from the bowels of the car, and suddenly the vehicle becomes an inanimate 2-ton object blocking traffic. Did you know that a simple parking error can decide if your car reaches 300,000 kilometers or if it becomes scrap metal before 50,000? That is why today we are going to gut the 21 most critical operating errors you commit every time you get behind the wheel. Stay, because error number 7 is something that 90% of people do wrong every day, and it is a time bomb for their pocket. Number 21. Shifting to parking position while in motion. The error number 21 is the ultimate expression of impatience at the wheel and one of the most destructive for the physical integrity of the transmission. It frequently occurs when you are arriving home or at work. The car is still moving by inertia at a few kilometers per hour, and before the tires come to a complete stop, you slide the lever towards the park position. At that precise moment, a violent battle breaks out inside the gearbox that no mechanical component is designed to win. To understand the damage, you have to visualize the parking pole. Imagine a cogwheel that rotates together with the car wheels and a small metallic arm, similar to a claw, that tries to fit between those teeth to block movement. If the car is still moving, that wheel is rotating. By forcing the claw, it begins to jump over the metal teeth, generating a rapid knocking sound that many mistake for a simple adjustment, but which is actually the sound of metal being devastated. This repetitive impact can break the claw completely, or even worse, send hardened metal fragments into the transmission oil stream. Once those shavings enter the system, they act like a virus. They travel through the valve body, scratching the internal cylinders and blocking the solenoids that control gear changes. The final result is usually a transmission that jerks, that stays dead in one gear, or that simply stops locking when you park, turning your car into a public danger that could roll downhill at any moment. Mechanics call this the lazy person error, because avoiding it only requires waiting one more second for the speedometer to mark 0. If you value your bank account, make sure the world stops before your hand touches that selector. Number 20. Putting neutral at traffic lights. The position number 20 leads us to an eternal debate that has caused more breakdowns than solutions. Many drivers have the erroneous belief that shifting the transmission to neutral while waiting for the light to change to green helps to save fuel or reduce the load on the engine. This practice is a vestige of the times of carburetors and manual gearboxes, but in a modern automatic transmission, it is a recipe for premature wear of the clutch packs and pressure seals. When you keep the car in drive and step on the brake at a traffic light, the torque converter is doing its job, absorbing the engine energy through the hydraulic fluid. There is no physical contact that generates wear at this point. The oil simply circulates and heats up in a controlled manner. However, by moving the lever to neutral and then putting it back into direct gear when the light changes, you force the gearbox to perform a complete pressurization cycle. The solenoids must open, the fluid must fill the drums, and the clutch discs must engage under pressure to start the movement. Repeating this unnecessary maneuver 50 times a day in heavy traffic adds thousands of friction cycles per year that the gearbox should not have suffered. Over time, this causes shifts to become erratic or for you to feel a sharp thud every time you put the car in gear. Additionally, there is a safety risk. If you need to perform a quick evasive maneuver to avoid a rear-end collision, you will lose vital seconds re-engaging the gear. The golden rule of the experts is simple. If the car is going to stop for less than 3 minutes, the lever does not move from its place. Your transmission will thank you with years of extra service. Number 19. The neutral drop or neutral launch. In the number 19, we find one of the most abusive and visually attractive practices for inexperienced drivers, but which transmission specialists consider mechanical suicide. It involves revving the engine while the car is in neutral and then suddenly moving the lever to the driving position. The goal is usually to bolt away with a squeal of tires, but what actually happens is a hydraulic and mechanical shock that can fracture the transmission housing. When the engine revs up in neutral, the transmission oil pump rotates at high speed, generating immense pressure that is waiting to be released. By suddenly engaging direct gear, all that energy is instantaneously transferred to the friction discs and planetary gears that are static. It is like trying to stop a circular saw with your bare hands. The heat generated in that microsecond of sliding is so extreme that it can glaze the clutch material, causing them to lose their gripping capacity forever. The damage is not limited to the discs. The impact can twist the input shafts, break the engine mounts, and even damage the differential. Many modern vehicles have electronic protection systems to prevent this, but even with them, the stress you subject the internal rubber seals to is devastating. A seal that fails due to excess pressure means the gearbox will lose the ability to keep the gears engaged, resulting in a repair that usually exceeds the market value of a used car. If you're looking for adrenaline, buy a racing car. If you're looking for reliability, never treat your daily car as if it were a drag racing toy. Number 18. Relying exclusively on the parking position. The error number 18 is so common that it has become a dangerous social norm. Parking the car, putting the lever in P, and getting out without activating the handbrake. If you are one of those who blindly trusts that small position of the lever, especially on slopes, you are playing Russian roulette with the integrity of your transmission and possibly with the safety of your surroundings. As we have already mentioned, the parking position depends on a small component called a powel. When you leave the car on a slope without the handbrake, the 2 tons of weight of your vehicle rest entirely on a metallic piece no larger than a human finger. This creates a brutal lateral tension on the internal bearings and gears. Have you ever noticed that when wanting to leave a slanted parking space, the lever is extremely hard and makes a violent clonk sound when moving it? That sound is the pawl releasing under extreme pressure, which erodes the metal and weakens the mechanism. The correct way to do it, approved by any automotive engineer, is a 4-step ritual that saves lives and transmissions. First, you stop the car completely with the foot brake. Second, you put the lever in neutral. Third, you activate the handbrake firmly and release the foot brake to let the wheel brakes absorb the weight of the car. Finally, and only then, you move the lever to the parking position. In this way, the powel remains free of load and only acts as a secondary safety measure. If you ignore this procedure, do not be surprised when one day the lever gets blocked. Or even worse, the mechanism gives way and you find your car in the driveway of your neighbor's house. Number 17. Switching between forward and reverse gear without stopping. We reach position number 17, a habit error that we usually commit when we are in a hurry maneuvering in tight spaces. It is that tendency to put the car in reverse while the car is still rolling a bit forward or vice versa. It seems like a fluid and professional maneuver, but for the valve body of your transmission, it is the equivalent of a mechanical short circuit. Automatic transmissions work by redirecting hydraulic fluid through a labyrinth of passages. When you change direction, the computer must close certain clutches and open others. If the car is still moving in the opposite direction, the internal parts are rotating in one direction while the system tries to force them to rotate in the other. This generates a heat spike and massive friction on the discs that are not designed to brake the vehicle but to transmit power. The wheel brakes are cheap and easy to change. The internal clutches of a transmission require removing the entire gearbox and disassembling it to the last screw. Drivers who commit this error frequently usually notice that over time, the car takes longer to engage the gear when they change position, or that there is a delay followed by a strong thump. This indicates that the internal seals have started to give way, or that the friction discs have worn down to the point of not being able to bite firmly. The rule is immovable. The car must be at 0 km/h with your foot on the brake before any change of direction in the lever. It is a second of pause that will save you thousands in workshop bills. Number 16. Descending slopes in neutral. The error number 16 is a fuel-saving myth that refuses to die, even though modern engineering has rendered it obsolete. Many drivers, when faced with a long downhill stretch on the road, decide to put the lever in neutral, thinking that the engine will rest and the car will roll freely without spending a single drop of gasoline. This is one of the most dangerous decisions you can make, both for your physical safety and for the health of your automatic transmission. In the first place, let us talk about lubrication. Automatic transmissions depend on an oil pump that is driven directly by the engine. When you put the car in neutral but the wheels continue to turn at high speed due to the inertia of the slope, the internal parts of the gearbox continue to move rapidly. But the engine, being at idle, makes the oil pump work at its minimum capacity. This means that you are forcing the internal components to rotate with insufficient lubrication and cooling. It is a silent wear that cooks the transmission from the inside out. Furthermore, from the point of view of savings, modern electronic injection systems are much smarter than the average driver. When you leave the car in a direct gear while descending, the system detects that you are not stepping on the accelerator and cuts the fuel supply almost completely, using the movement of the wheels to keep the engine turning. In neutral, the engine must consume fuel so as not to turn off. But the most serious thing is the loss of control. Without the engine brake, you subject the brakes to a brutal thermal stress that can lead to them failing just when you need them most. Number 15, towing the vehicle incorrectly. We reach position number 15 with an emergency situation that usually ends in mechanical tragedy. Imagine that your car stops due to an electrical failure, and you decide to have a friend tow you a few blocks to the nearest workshop using a rope. If your car is automatic and you allow the drive wheels to spin on the asphalt while the engine is off, you are destroying your transmission in real time without even having started the car. As we mentioned previously, the transmission oil pump only works when the engine is on. If you tow the car with the wheels in contact with the ground, the planetary gears and the friction discs are forced to rotate by the mechanical force of the wheels. But there is no fluid circulating to lubricate them or to dissipate the heat generated by that rotation. In less than a couple of kilometers, the dry friction can reach temperatures so high that the internal components weld together, turning a simple electrical breakdown into a repair of thousands of dollars. The only safe way to transport an automatic vehicle is on a flatbed where none of its drive wheels touch the ground. If you have no other option, and the manufacturer manual allows it under extreme conditions, you should never exceed 30 kilometers per hour or travel distances greater than 5 kilometers. However, the risk is so high that the professional recommendation is blunt. If the engine does not turn, the wheels should not either. A flatbed crane service is infinitely cheaper than a new gearbox. Number 14, not using the handbrake at all. The error number 14 is an extension of the habit of trusting only the parking position, but it focuses on total negligence toward the handbrake or parking brake system. Many drivers believe that the handbrake is something only used in manual cars or when parking on extremely steep hills. In an automatic, this is a conceptual error that generates unnecessary fatigue in the entire powertrain. When you park on a surface that seems flat, there is always a slight inclination that not even the human eye perceives. By releasing the brake pedal without having activated the handbrake, the car moves a few centimeters until the transmission pole locks. That small sway you feel is the total weight of the car hitting against the internal mechanism of the gearbox. Over the passage of months and years, this constant impact generates play in the engine mounts, in the constant velocity joints, and, of course, in the locking mechanism of the transmission itself. The handbrake is designed to hold the car using the discs or drums of the wheels, which are external wear components and easy to replace. The transmission is designed to move the car, not to serve as a permanent anchor. Getting used to always putting the handbrake on, even in your home garage, ensures that the transmission remains relaxed while the car is not in use. It is a change of habit that costs nothing and that protects the precision of gear changes in the long term. Number 13, ignoring small fluid leaks. In position number 13, we enter the field of failed preventive maintenance. Often, drivers notice a small reddish stain on the garage floor and decide to ignore it because the car continues to shift gears well. This is the mechanical equivalent of ignoring a wound that does not stop bleeding. In an automatic transmission, the fluid level is not a suggestion. It is a critical operating requirement for the system to function. Unlike engine oil, which lubricates and cleans, the transmission fluid is also the medium through which power is transmitted and shifts are executed. If the level drops even a little due to an old gasket or a dried-out seal, the hydraulic pressure inside the valve body begins to fluctuate. This causes the clutch discs not to be pressed with sufficient force, which generates a slight slip. That slip produces heat, and heat is the number one enemy of the automatic transmission. A transmission that operates with little liquid burns inside long before any warning light turns on the dashboard. By the time you feel the car slipping or that the revolutions go up without the car moving forward, the damage is usually already irreversible. Visually checking under the car once a week and verifying the fluid level if your car has a dipstick is the most economical way to avoid the scrapyard. An oil stain is a cry for help from your car. Do not wait until it goes silent. Number 12. Keeping your foot on the accelerator while changing gears. The error number 12 is a driving vice that occurs mainly when performing fast maneuvers, such as a U-turn, or when leaving a parking lot in a hurry. It consists of not releasing the accelerator pedal while you move the lever from reverse to drive or vice versa. Although most modern gearboxes have electronic protections, Forcing the engagement of a clutch pack while the engine is revving up is an unnecessary mechanical aggression. When the engine is at 1,500 or 2,000 revolutions per minute and you engage a gear, the difference in speed between the engine and the transmission must be absorbed by the fluid and the discs. By keeping the accelerator pressed, you are eliminating the smooth synchronization phase that occurs during idling. The result is a whiplash that travels through the entire driveline, from the torque converter to the drive shafts. This habit not only wears down the friction materials but also stretches the internal chains, in the case of CVT-type gearboxes, or damages the planetary gears in conventional gearboxes. The correct way to operate is always to lift your foot off the accelerator, wait for the engine to drop to its resting revolutions, perform the gear change, feel that the transmission has engaged, it usually takes half a second, and then accelerate again. Fluidity in operation is the signature of a driver who knows how to take care of their investment. Number 11, forcing the engine when cold. Finally, we close this first section of the chapter with position number 11, an error that affects both the engine and the transmission. Many drivers start the car in the morning and immediately head out to the main avenue, demanding maximum acceleration. What they forget is that the transmission fluid is much thicker when it is cold and does not flow with the same ease through the narrow channels of the valve body. In low temperatures, the transmission oil needs a few minutes to reach its optimal operating temperature, which is when its viscosity properties allow for total protection. If you demand fast gear changes and high revolutions with cold oil, the internal seals suffer excessive pressure and the discs may not receive adequate lubrication, causing premature wear due to metal-on-metal contact. It is not about leaving the car running for half an hour at your front door, which is also inefficient, but about driving smoothly during the first 5 or 10 minutes. Avoid full accelerations and allow the temperature needle to rise before asking the transmission to work under stress. This small gesture of morning patience can be the difference between a gearbox that lasts 10 years and one that begins to fail at 5. Number 10. Stepping on the brake and the accelerator at the same time. Brake boosting. The error number 10 is one of the most devastating practices a driver can inflict on an automatic transmission, often referred to in the performance world as brake boosting or stall speed launching. This technique consists of stepping on the brake pedal with the left foot with all possible force while simultaneously accelerating with the right foot with the selector in the driving position. The objective is to allow the engine to increase revolutions and generate boost pressure in turbo engines, or simply to reach its peak engine torque before releasing the brake for a lightning-fast acceleration. However, what happens inside the transmission housing is a process of accelerated thermal destruction that few components can withstand. In a conventional automatic transmission, the engine and the gearbox are connected by the torque converter, a hydrodynamic component filled with fluid. When you perform this maneuver, the engine is trying to turn the internal turbine of the converter with immense force, but the wheels are locked by the brakes, which means the transmission input shaft cannot move. In this scenario, 100% of the kinetic energy produced by the engine that is not converted into movement is transformed by laws of thermodynamics into pure heat within the transmission fluid. In a matter of seconds, the oil temperature can soar above 150 or even 200 degrees Celsius, instantly exceeding the chemical breakdown point of the fluid. This instantaneous heating causes what chemists call thermal oxidation. The transmission fluid, ATF, loses its lubrication properties and its protective additives degrade, turning into a sticky and acidic varnish. This varnish begins to deposit on the most delicate components, such as the control solenoids and the valves of the hydraulic body. Additionally, extreme heat causes the elastomer seals and rubber gaskets to become brittle. A single session of this type of driving can reduce the useful life of the transmission by tens of thousands of kilometers, leaving the friction discs charred and a hydraulic system prone to catastrophic failures due to obstruction from burned sediments. Number 9. Ignoring slight jerks or slipping. The position number 9 focuses on an error of diagnosis and attitude, complacency in the face of early symptoms of failure. Many drivers notice that occasionally the transmission performs a gear change erratically with a small metallic thump, or what is technically known as slipping, where the engine revolutions rise disproportionately before the next gear engages with a jerk. Being symptoms that sometimes disappear after a few minutes of driving or that occur only sporadically, there is a tendency to think they are quirks of the car. This is a negligence that transforms a repair of a few €100 into a complete replacement of thousands. Slipping is the unmistakable sign that the friction discs within the clutch packs have lost their gripping capacity. These discs are coated with a ceramic material or specialized paper that allows them to engage smoothly under hydraulic pressure. When the pressure is insufficient, due to a tired solenoid or degraded fluid, or when the friction material has worn out through use, the discs slip against each other. This friction generates localized extreme heat that releases microscopic particles of burned material. These particles travel throughout the transmission circuit, acting as an abrasive agent that sands the internal walls of the oil pump and the passages of the valve body. Ignoring these jerks is allowing the transmission to self-cannibalize. Every time you feel that jerk, the transmission is losing structural material. What starts as a simple delay in the application of pressure can result in sediments completely blocking the transmission filter, causing a total loss of pressure and leaving the vehicle immobilized. Modern technology allows, through a professional scanner, the observation of the adaptation times of the clutches. If the computer detects that a clutch takes longer than normal to close, the system is warning that the end is near. Addressing the problem at this point allows for cleaning and changing solenoids, but if one waits until the slipping is constant, the only real solution will be a total reconstruction. Number 8. Not warming up the gearbox in extreme climates. In the number 8, we address the physics of fluids under low temperature conditions. There is an erroneous belief that only the engine needs to warm up before starting the journey. The reality is that the automatic transmission fluid, ATF, is much more sensitive to viscosity changes than engine oil. In climates where temperatures fall below 0 degrees, the ATF becomes extremely thick, losing its ability to flow quickly through the labyrinthine channels of the valve body, which have barely the diameter of a human hair. When a driver starts the car on a freezing morning and puts it in drive immediately to drive away accelerating, they are subjecting the transmission to massive hydraulic stress. Due to the high viscosity of the cold oil, the transmission pump must make a much greater effort to move the fluid. This can generate cavitation, a phenomenon where air bubbles form in the oil that, upon collapsing, hit the metallic surfaces with an erosive force. Additionally, gear changes occur with a significant delay because the fluid takes more time to fill the piston chambers that activate the clutches. This delay causes the friction discs to rub against each other for a longer time before locking completely, which accelerates wear exponentially. To avoid this damage, it is not necessary to leave the car at idle for half an hour, which is inefficient and polluting. The correct method is to start the engine and, after 1 minute, slowly move the lever through all positions: parking, reverse, neutral, and drive, holding each position for about 10 seconds. This forces the fluid to circulate through the different circuits and to warm up through controlled friction in the torque converter. Once the journey has started, one should drive with extreme smoothness, avoiding strong accelerations or gear changes at high revolutions until the engine temperature indicator has reached its normal operating point, which usually coincides with an acceptable temperature of the gearbox fluid. Number 7. Using any universal oil. The position number 7 is one of the greatest causes of sudden death in modern transmissions: the use of incorrect fluids. Formerly, almost any car could use a type Dexron 2 or Mercon fluid. Today, transmissions are extremely specific pieces of engineering with unique mechanical tolerances and chemical requirements. However, many independent workshops and spare parts stores promote so-called universal or multi-vehicle fluids, claiming that they meet the specifications of dozens of different manufacturers. This is a chemical simplification that can be fatal. Each transmission fluid is formulated with a very specific additive package that determines its viscosity, its resistance to oxidation, its ability to dissipate heat, and, most importantly, its friction coefficient. Some transmissions require a fluid that is very slippery to allow imperceptible gear changes, while others, such as double clutch or high torque ones, need a fluid with friction modifiers that help the discs to engage with immediate firmness. If you use a universal fluid in a gearbox that requires a high friction technical specification, the discs will slip constantly. On the contrary, if you use a fluid that is too aggressive in a gearbox designed for smoothness, the changes will be abrupt and will damage the engine mounts and internal gears. In addition to the friction problem, there is the question of chemical compatibility with internal materials. The gaskets, the piston seals, and the insulation of the internal transmission cables are manufactured with specific polymers. A fluid with an incorrect additive package can cause these seals to swell, shrink, or chemically degrade, causing internal pressure leaks that the driver will not notice until the transmission stops working completely. The golden rule is absolute: Never accept a fluid that does not explicitly indicate on the container that it meets the exact standard of your car manufacturer. For example, ZF Lifeguard 8, Toyota WS, Mercedes-Benz 236.15. Saving a little money on the oil is the most expensive investment you can make. Number 6. Washing the engine with pressure water. We reach number 6 with an error born of aesthetics and misunderstood cleanliness. The engine bay of a modern car is a jungle of sensitive electronics, and the automatic transmission is, in essence, a computer that manages hydraulic pressure. Around the gearbox housing are multiple speed sensors, temperature sensors, and above all, the main connector that communicates the control unit with the internal solenoids. These components are designed to resist ambient humidity, road splashes, and extreme heat, but they are not designed to withstand a jet of water at 100 bars of pressure coming from a pressure washer. When a person points the pressure water lance toward the transmission to remove dust or small oil stains, the force of the water is capable of overcoming the rubber seals of the electrical connectors. Once water penetrates the interior of a connector, the combination of electricity and minerals in the water starts a process of electrolysis and galvanic corrosion almost immediately. With the passing of days, the metallic pins become covered in a green oxide that increases electrical resistance. This causes the signals sent by the sensors to arrive corrupted to the computer. A transmission that receives erratic electrical signals will begin to behave unpredictably. It may decide to downshift suddenly at high speed or enter protection mode or limp mode, where the gearbox locks in a single gear, generally third, to avoid major damage. The worst thing is that this damage is usually intermittent and very difficult to diagnose for a general mechanic, which leads to changing expensive parts when the problem was simply a sulfated connector. If you decide to clean the engine, do it with the engine cold. Use specific degreasing products applied with a sprayer and rinse with a stream of water without pressure, always protecting the electrical components with plastic. Number 5. The error of different sized tires. The error number 5 seems at first glance to be a chassis maintenance problem, but its impact on the transmission is direct and devastating. Modern automatic transmissions depend entirely on the data they receive from the wheel speed sensors, ABS sensors. These sensors inform the transmission computer exactly at what speed each tire rotates. If you mount tires of different brands on the same axle, or if you have one new tire and another very worn one, the total diameter of the wheel varies. Although the difference is barely a few millimeters, that wheel will have to rotate at a different speed to cover the same distance as its partner. For the transmission computer, this difference in rotation is a signal that something is wrong. In many vehicles, the system will interpret that a wheel is losing traction, unnecessarily activating the stability control systems or constantly adjusting the torque converter slip to try to compensate for the supposed loss of grip. This generates a constant duty cycle on the internal components that should be at rest during linear driving. In four-wheel drive AWD vehicles, the damage is even faster. The difference in rotation forces the center differential or the transfer clutch to work continuously to digest that difference in speed, which overheats the transfer fluid and ends up breaking the internal discs in a few months. Even something as simple as having very unequal inflation pressures can generate this effect. A wheel with low pressure has a smaller effective radius and rotates faster. Therefore, transmission maintenance also involves the tires. It is vital that all four tires are the same model and size and that rotations are performed every 10,000 kilometers to ensure that wear is uniform. If you suffer a puncture and must use the spare wheel, which is usually smaller in size, drive at low speed and only the minimum distance necessary to the workshop. Otherwise, you will be cooking the differential and the transmission of your car due to a simple matter of geometry. Number 4. Not checking coolant leaks, lethal mixture. In position number 4, we find the most catastrophic scenario for an automatic transmission, known in mechanical slang as the strawberry milkshake or pink milk. As we have mentioned previously, the transmission needs to cool down, and for this it uses a heat exchanger that, in most vehicles, is integrated inside the main engine radiator. The transmission fluid circulates through internal ducts surrounded by the engine coolant. The problem arises when the radiator ages or when a poor quality coolant is used that corrodes the internal walls of this exchanger. If a small crack occurs in the internal duct, the pressure of the engine cooling system, which is usually constant, pushes the antifreeze into the interior of the transmission circuit. At the moment when the coolant, which is basically water and glycol, mixes with the transmission fluid, ATF, a disastrous chemical reaction occurs. The water instantly destroys the glue that keeps the friction material adhered to the steel discs of the clutches. In a matter of minutes, the friction material peels off as if it were wet paper, floating throughout the transmission and clogging every oil passage. This phenomenon is called strawberry milkshake because the red oil, when mixed with white or green coolant, takes on the appearance of a thick pink cream. Once this fluid enters the transmission, the damage is practically irreversible. The rubber seals swell and deform, and the internal electronic components suffer short circuits. The only way to prevent this is to perform rigorous maintenance of the engine cooling system, changing the antifreeze every 2 years to prevent it from becoming acidic and eating away the radiator from the inside. If you ever check the coolant level and see oil spots, or if the transmission oil looks milky, do not move the car. Detection in the first 5 minutes could save the gearbox, but 5 kilometers later, the transmission will be scrapped. Number 3. Driving with a defective cooling system. The error number 3 is an extension of the previous one, but focused on operational thermal stress. Many drivers ignore minor temperature problems in their engines, such as a thermostat that sticks from time to time, a fan that makes noise, or a radiator partially obstructed by external dirt. The logic of the average driver is, as long as the needle does not reach the red zone, there is no problem. However, for the automatic transmission, working a few degrees above its ideal temperature is a slow and silent death sentence. There is a rule of thumb in transmission engineering. For every 10 degrees Celsius that the fluid operates above 90 degrees, its optimal temperature, the useful life of the oil is reduced by half. If the normal temperature of your engine is 90 degrees, but due to a deficient cooling system it is working at 100 degrees, your transmission oil is degrading twice as fast as normal. At 110 degrees, it degrades 4 times faster. Excessive heat breaks the molecular chains of the oil, transforming it into a watery liquid that can no longer maintain the hydraulic pressure necessary to hold the clutches firmly. When the oil is overheated, the transmission begins to experience what we call soft shifts. The driver notices that the car feels sluggish, as if it were struggling to move forward. This is because the internal clutches are slipping slightly due to the low viscosity of the hot oil. This slipping generates, in turn, more heat, creating a vicious cycle that ends with the carbonization of the fluid. Keeping the radiator clean of insects and dirt, ensuring that the fans work at all their speeds, and changing the thermostat preventively are engine maintenance tasks that have a direct impact on the longevity of the transmission. Number 2. Turning off the car in a gear other than P. The position number 2 refers to a shutdown habit that seems harmless but can generate severe conflicts in the electronics and mechanical safety of the vehicle. Many drivers, upon reaching their destination, have the habit of turning off the engine while the lever is still in drive or reverse, and only afterwards move the selector to the parking position. In modern vehicles with electronic selectors, the car usually moves the gearbox to P automatically, but this generates unnecessary stress on the electric actuators and the computer logic. The main problem lies in lubrication and pressure management. When you turn off the engine, the transmission oil pump stops rotating instantly, eliminating all hydraulic pressure from the system. If the car moves slightly, even if it is just a few millimeters while you are moving the lever from D to P with the engine off, the internal components move without the protection of the pressurized oil film. Furthermore, in automatic gearboxes, the parking position activates a mechanical component called the parking powel, which is a small metallic wedge that blocks the output shaft. If this powel is inserted while the car still has a minimum of inertia and without the assistance of the hydraulic pressure that manages the smoothness of the mechanism, a sharp thud occurs that, over time, can wear down or break the pole, leaving the car without the ability to lock in parking. From an electrical point of view, turning off the engine in a gear other than P can leave the transmission control unit, TCM, in a state of confusion. When restarting the vehicle, the computer must perform a series of checks to verify the actual position of the internal valves. If there is a discrepancy between what the computer remembers and what the sensors detect upon starting, the car could show an error on the dashboard or, in extreme cases, prevent the engine from starting for safety. The correct protocol must always be: stop the car completely, put on the handbrake, move the lever to P, and finally, turn off the engine. Number 1. The habit of coasting in neutral on downhill roads. We have reached the most serious error, number 1 on our list of destructive driving habits: coasting or driving in neutral on downhill slopes. This is a persistent myth that comes from the era of cars with carburetors. where it was believed that putting the car in neutral on a downhill saved fuel because the engine dropped to idle. In a modern car, this is not only false. The injection system cuts off fuel completely when you go down in gear, but spends gasoline to maintain idle in neutral. But it is a guaranteed way to destroy your automatic transmission. The design of an automatic transmission depends critically on the relationship between engine revolutions and wheel speed. The oil pump, which provides lubrication and cooling to all planetary gears and friction discs, is connected directly to the input shaft, engine. If you put the car in neutral while going down a slope at 100 km per hour, the engine drops to about 800 revolutions per minute. At those revolutions, the oil pump delivers the minimum lubrication flow. However, the wheels are spinning the output components of the transmission at a very high speed. You are forcing the internal components to spin at high speed while lubrication is practically non-existent. This lack of lubrication causes dry friction heating in the bearings and planetary gears. Furthermore, being in neutral, the fluid does not circulate with enough force through the external cooler, so the heat generated by inertia remains trapped inside the housing. But the danger is not only mechanical, it is about safety. In neutral, you lose engine braking, which forces you to abuse the service brakes, which can overheat and fail, fading phenomenon. And if you need to accelerate suddenly to avoid an obstacle, the delay while the computer tries to synchronize the engine revolutions with a transmission spinning at high speed will cause a brutal mechanical impact when engaging the gear, which could break the gearbox mounts or even the drive shaft. Never, under any circumstances, put the transmission in neutral while the vehicle is in motion. Arriving at the end of this technical analysis on chemistry and habits, it remains clear that the longevity of an automatic transmission is not a matter of luck, but the direct result of a discipline of maintenance and operation. We have broken down how heat is public enemy number one, whether generated by aggressive maneuvers such as brake boosting or by negligence in the engine cooling system. We have understood that the transmission fluid is not a simple oil, but a precise engineering component that does not admit universal substitutes or contamination with water. The care ritual for an eternal transmission is summarized in respecting the physics of the system, allowing the fluid to reach its working temperature before demanding effort, ensuring that the tires do not confuse the electronic sensors and, above all, understanding that the gear lever is not a toy to save fuel on downhills.